the U.S. Department of Housing and Urban Development, they actually have, this is a good resource if you haven't heard of it before, but it's what they call the noise notebook. And there's several different strategies outlined in the noise notebook, covering topics from eliminating sound to sound absorption, sound barriers, and just other design strategies that we can implement into our homes and our buildings to reduce the sound coming in and improve the living space that we have. And so sound really travels in really two different manners. First, it goes through the air, and then second, it can travel through solid materials. And this is a very, very basic diagram of how sound travels. First, on the left-hand side of your screen, you can see incoming sound, and most of that sound is then reflected back out to the outside. But then some of that sound can be absorbed inside the acoustic barrier, and then everything else is that's not either reflected or absorbed is then transmitted to the inside right there. And when we measure sound, most of the time we're talking decibels, and in other terms, loudness or volume sometimes. So, so this is a very, very basic diagram of how sound can, what happens to sound, either reflected, absorbed, or transmitted. And when we're talking transmission loss, we're really just talking the difference between incoming sound versus what's really transmitted here. And when you look at decibels or sound pressure, that can really range from just a very, very soft whisper to regular human speech, all the way up to a rock band that can sometimes exceed 140 decibels. And so when we're talking about sound, reducing the amount of sound coming in from the outside, a reduction in 10 decibels is equivalent to reducing or cutting in half the amount of perceived sound that you hear. And conversely, if a reduction of 5 decibels is reducing the amount of sound that you hear by 25%, and then again, by a reduction of 20 decibels is reducing it by 75%. So this is a good chart, and this is, if there's one thing I just have to take away from today, this measure of how we measure sound transmission and the loss and what that can really do. Sound is also measured in frequency, and frequency is essentially how often something happens. And when it comes to sound, how often a sound wave can hit a certain object, right? And so you can see there's low frequency noises here, and moving up to middle frequency noises, all the way up to high frequency noises. And as you can see, each of those noises span a certain frequency right here. And the way we test sound is by a test called the sound transmission class. And this was originally developed to measure interior partitions, ceilings, floors, really interior spaces, separating one wall from another. But it is frequently used for exterior walls and then windows and doors. And this is just a small photo of what that test looks like. You can see that there's a transmitter on one side of the wall and a receiver on the other side of the wall. And the transmitter will send off random sounds at different frequencies, ranging from 125 hertz all the way up to 4,000 hertz. And as they're doing it, you'll see everything is plotted off into this chart right here. And the value, or the STC rating that a window is given lies at 500 hertz right there. And it shows that frequency because that's a common frequency for human speech. So again, we're really targeting those middle frequency ranges when we're talking about STC numbers on here. So when we're talking about different strategies or principles for improving STC ratings, there's really three areas that we need to focus on. The first is the density of the materials. Secondly, the overall thickness and also the variations in the thicknesses of the total composite of what that acoustic barrier is. And thirdly, and sometimes most importantly, is managing the air leaks. So just to give you some sort of perspective and of how STC ratings perform. So if you were to have an interior wall with 2x4 construction here with one layer of sheetrock, that would give you an STC rating of around 28. Now, if you were to add another layer of sheetrock to the other side of the wall, that you can see what kind of improvement that is, that jumping it up from 28 to 34. And then when we start to add in insulation inside that wall and then ultimately start to stagger or push those studs further away from each other from 16 inches to 24 inches on center, you can see what that does for the STC ratings right here. And keep in mind, every value of 10 that we're reducing the sound coming through, that's like cutting everything in half. So while 28 is still pretty good, 40 is going to be much, much better for your ratings. So when we take those same principles and apply those to how windows perform, you can see your standard dual pane insulated glass makeup right here on your left-hand side of the screen is often made up of two equal sheets of glass right here, made up of the same thickness, which is a lot of times a couple millimeters thick, and a common space in between. And that'll give you an STC rating of around 26. One common strategy to improve your STC ratings is to add a thicker layer of glass on the inside. Sometimes that could be positioned to the outside as well, but just by mixing the thickness of the layers from the inside, which will be 3 millimeters, and then 5 millimeters on the other side, you can see what that does to the STC rating right there. We do see a noticeable change from 26 to 30 right there. Well, then you may be thinking, well, why don't we just keep on adding more glass and go all the way to triple pane window? So most triple pane systems, what you get is 3 equal sheets of glass. But what happens is that airspace in between the glass a lot of times gets condensed down because the window can only be so deep. So with the loss of that airspace in between, and more importantly, with the sheets of glass that are all 3 the equal size, what happens is these 3 sheets all attenuate at the same frequency, or I like to say they speak the same language. So what you see here is an STC rating really close to the same as a dual pane glass. So ultimately, a triple pane window, depending on the makeup here, often is not that good in improving your sound ratings. Now, there are a lot of other good reasons to go to triple pane glass. They do perform better thermally. So, but when we're speaking strictly with sound ratings, they're not always the best solution. And then there's other solutions on the market. You can have a laminated glass, or even in some parts of local areas, we use hurricane glass windows, and you can see those can go all the way up to 36 STC, and that's a fantastic number right there. And but there's also a cost associated with that added performance with this laminated glass, or if you have a hurricane glass window, that whole window is really designed around other building codes as well. So you may be getting a product that's really over-designed for what you really need. And then your final example right here is showing a triple pane window again, but now you have a larger airspace right here, but an even larger airspace in your second layer right here. And so what you can see here is adding mass to one solution can add increase the STC rating, but also staggering your airspace in between the glass is also another a good strategy to employ right there. There are some other systems on the market that take advantage of both of these into the same system, where you may see 3 millimeter on one side, 5 millimeters here, and 4 millimeters here, and that can give you a rating of much higher than 36 right there as well. So we've been talking STC ratings so far, and how STC was originally developed for interior partitions. But there's also another test that's available for specifically for windows and doors, called the outdoor-indoor transition class. And this is actually a better measure of reducing outside noise, because the main difference here is in where your STC test, the low threshold for the frequency is at 120 hertz. The outdoor-indoor transition class drops that low threshold down to 80 hertz. So now we're able to measure those lower frequency noises, such as aircraft noise, traffic noise, railways, and all those lower frequency noises. So this is normally a better predictor of how well a window or glazing system will perform in reducing those specific sounds. And when the measurement is still the same, it's still measuring the number of decibels that we're reducing from outside noise. And just because, one thing that you may notice, right, if you look at the OITC numbers here, they're often lower than STC ratings. And really the reason for that is those lower frequency noises are much more difficult to mitigate through a glazing system. And so, so as you see on this chart right here, we have common decibel rate, STC ratings on the bottom here for windows and doors, ranging from your mid-20s all the way up to 40 here. And on your side right here, you see the amount of perceived reduction measured by percentages here. So in your basic window, that will normally block out about 82% of your outside noises. Which is actually very good. In fact, we have many customers tell us the first thing when they replace their windows is, I can't believe how quiet it is. So that's always great feedback. But if you want to take it one step beyond that, you can upgrade your glass, and what I mean by that is simply mixing those two thicknesses of glass. That would put you into the next category up. And where you were in the mid to upper 20s with an ST rating, now you have an improvement of about 5 or 6 decibel reduction there. And if you remember back earlier in the presentation, a reduction of 5 decibels is about 25% less noise that you would hear compared to that first category right here. And so that is a noticeable difference from the one category to another. And then when you work your way up into more advanced systems such as hurricane glass windows or additional storm panels, you can see this blue line right here will really show, as you're working your way into these higher categories, the difference in perceived sound gets less and less and less as you work your way up right here. So really the question then becomes, at what point does the cost outweigh the return? And so that's a discussion that you would have to explore with your clients and the architects that you're working with. And there are several solutions on the market that can really achieve very high ratings. And here you can see 2 solutions that will actually give you an STC rating of 48, which is off the chart. It's extremely high. And but there's always a downside. With higher performance, what's the trade-off? A lot of times that means higher cost. But in one example right here, we have a double hung window, or a double sash double hung window, where you have an insulated glass on the outside and essentially an operable storm window on the inside. So if you can imagine, if this were in your home, how would this operate, and what would you need to do to just open the window? You'd have to open one sash and then a second sash right there. Another consideration is, what does this window look like, and is it going to match the aesthetic of the rest of my home? Sometimes with these more complex systems, they have limitations in what the design looks like. And then how am I going to clean this window? If it gets fogged up inside this middle chamber, how am I actually going to clean that window? So other considerations with these high performance systems. The other example that you see on the right-hand side of your page is just simply adding an acrylic storm panel to the outside of an existing window. And now if we add this to that, then we lose the function of actually getting ventilation through the window. So that kind of eliminates part of the reason for having the window. And some windows also need to meet egress and other building codes as well. So you can't always use this type of solution. And also acrylic panels can tend to fade and discolor over time as well. And there's other thermal properties and considerations to think about as well. So to really do a good job of exploring all your options and making sure you have the right solution for your customer. And also right here, one of the most important details to think about when we're trying to reduce the amount of sound coming in from the outside is the importance of making sure we reduce the number of air leaks. And I like to make the analogy that sound can behave a lot like cold air. And so if you have any kind of leaks coming through the windows, you would definitely feel those drafts coming through in the wintertime. Well, sound is going to be very similar to that as well. So just ensuring that the window and the weather stripping and gaskets are all making good contact within the window frame and in that intersection between the frame and the sash is very important. But also outside the window frame, and how is that all detailed out? Is it flashed properly? Is there a good seal between integrating that window to the rough opening right there? Do we have flashing tape right there, which has another purpose as well? But other important elements to the overall performance of a window, including sound, is this interior seal. A lot of times that would be low expansion foam, and then your exterior seal right here as well. This isn't just for waterproofing, people. This is also for sound performance, and a lot of times your air leaks. Those, if we can reduce those, that's going to help with your HERS rating at the completion of the project as well. So just making sure you have an airtight seal all throughout the window and integrated in through the rough opening is a very important detail. So some site-specific details. Certainly not every job site is going to be the same. So you really have to take a very close look at what are the surrounding, what's the surrounding environment look like? Are we in close proximity to a highway or air traffic? Flight patterns. What's the use of our building or the resident? Many times we're in residential projects as well. So, and where are the what rooms are facing these highways if we are going to be close to these major highways? Are there any special functions for the interiors, or even if it's a living room next to the highway, or other loud noises coming from the outside. And just have to be aware of our physical surroundings, what else is around the house that we're working on. Certainly the cost, there's a cost versus benefit that we talked about in these different glazing solutions, whether it be just simply mixing the thickness of the glass, all the way going all the way up to laminated glass, or even some custom solutions. And how good of performance do we need? And certainly, sound performance is not everything. Most of it, like I said earlier, energy performance is always a big topic as well with many homeowners, and just finding the right balance between energy performance, sound performance, the cost. Those are all different areas to consider. So I wrapped up a little bit early, so I just wanted to share with you my information, and I'm not sure if we have any questions. I'd be happy to field any of those questions if anyone has them. And but if not, my information is right here on the side of the screen here. Feel free to reach out to me directly. My cell is always a good way to reach out to me. Email is great as well. I'd be more than happy to discuss with you more in depth how we can help mitigate the sound on your projects, or if you have other concerns on your projects, feel free to reach out to me anytime. So I'm not sure if we have any questions from the audience today. I'll give it a minute or two, but otherwise I'll turn it back over to Michelle. No? Okay.
I have a quick question. Can you hear me?
Yeah, Justin, go ahead.
Yeah, I was just wondering, so in your recommendation, well, and you may have covered this, and it was a really informative, great presentation. I learned a lot, especially the low frequency stuff. I did not know that before. But do you recommend a certain window type, like a double hung over a casement? Is there, obviously a fixed window like your plexiglass example is going to limit, have the highest STC rating. But what is the best window type to put in if you do have issues like that?
Yeah. So that can be very design specific between different products. From what I've seen, Justin, is the fewer gaps, and this kind of goes back to the discussion of eliminating air leaks. And on a double hung window, we see a lot of double hung windows in our market. They're very, very traditional, but double hung windows just by nature have two sashes. Sometimes you see triple hung windows with 3 sashes. And so that can, the more sashes you have on a window or even door, the more potential you have for air leaks. And even though we can make sure that the double hung window is installed very, very well, plumb level square, all the weather stripping is in good contact, there's just more potential for air to come through that window. So I guess to answer your question, casement windows, when we're talking venting windows anyway, casement windows and awning windows would be the best outside of fixed windows, and where fixed windows would certainly be at the highest level. So I hope that answers your question.
Yes, Jared. Vaughn Salmi here.
Hey, Vaughn, how are you doing?
Good, thank you.
Good.
Quick question in terms of the additional and increased weight in the glazing patterns here for this. Does Pella take and do anything structurally to the frame of their sash to handle the extra weight that goes in, or do they use their standard size sash for this additional glazing on the increased STC rated glass?
Yeah, that's a great question. I'm glad you brought that up. So So we looked at different glazing solutions, and in the standard platform or standard chassis that we have in our sash that we have, that will accommodate that mixed millimeter where you saw two sheets of glass, but one of those will be just a little bit thicker, right? So that standard sash chassis can accommodate that. The trade-off there is that your airspace can get reduced down a little bit. So sometimes you might see a little trade-off with your thermal numbers if you go that direction. And that's really dependent on the overall design of the window as well. So it's not always about just the glazing. But when you do bump up to triple pane, that will really require the overall depth of that is about 1.25 inches. So which most standard sash don't accommodate. So that's where we do have to beef up the sash platform of that. But generally the frames aren't really affected with that. So a lot of times we're using the same frames, we're just changing how deep that sash is.
Right. Yeah, just in the sash itself, is there any differential when you go into triple glazing? Is there any differential in the hardware systems that are used for that?
Yeah, for sure. And when it comes to double hung windows, what we have to do from a manufacturer standpoint is upgrade the balances, because those sashes are significantly more heavy than dual pane glass. So that's one of the bigger changes that we have to make, and that would actually live inside the frame. When it comes to casement windows, we do sometimes change the roto mechanisms, the crank mechanisms, because there's just more weight bearing down when you crank open that window. So if it gets to a certain size on the casement windows, that's when we flip over the hardware for that too. That's a great question.
Great, thank you.
Yeah, great. Thanks for the question. So I think we just have a couple more minutes. I'm not sure if Michelle is on. If I could kick it back to you, or if there's any other questions.
Is there anybody else who has any questions? We probably have time for one more. Good. Well, this has been a great session. Thank you so much, Jared. We have a hard stop today at 5 o'clock, but I did want to say thank you to everybody for being here and being a part of this first experiment for us with the networking and seminar today. So thank you so much to Pella. Thank you to everybody who's attended today. And I probably will be reaching out to all of you to get some feedback on how today went, and so that we can continue to have more events like this in the future. So everybody have a great day. If you're heading on to mindfulness with Peter at 5 o'clock, enjoy that. Otherwise, I hope to see all of you very soon. Have a good afternoon, everybody.
Thanks, Jared. Thanks, Michelle.
Thanks.